Hi there and welcome to Code Framer. In the last video we understood about all the topics that we are going to cover as part of this particular tutorial, where we will be understanding about all the design patterns in Python. So as I said earlier in the previous video that we will be starting with the single responsibility principle first. But before understanding about the solid design principles, I wanted to discuss or give you an understanding about what is basically this solid design principle, or what is the meaning of this solid, and why do we even need solid design principles in order to design our software applications. So in this video I will just explain about the solid acronym and also will give an introduction to the solid design principle, and then we will discuss about all the solid design principles individually, where we will just have a look at their definition. But I won't explain these solid design principles in this particular video because it is pointless to explain these principles without giving examples. So we will just see the definition of those solid design principles in this video, and finally we will also have a look at what are the advantages of using solid design principle, and also what will happen if you do not use the solid design principle while designing your software application. So these are some important points that you must know before understanding about the solid design principles themselves. So having said that, let us begin. So the first question is, what is a solid design principle? So basically a solid design principle are the design principles that enables us to manage most of the software design problems. So as you could expect that initially, when there were no design principles or design patterns at all, then the software developers who were developing these softwares using the object-oriented programming must have undergone certain design problems, and they would have found a particular pattern using which we can basically solve these software problems, or we can say software design problems. So which clearly means that these solid design principles are basically created to avoid any such software design problems that we may encounter in future if we do not follow these solid design principles, or we do not follow these rules which we need to consider during the design of our software application. So now let us see what is the meaning of this term solid. So solid is nothing but an acronym where we have 5 design principles, which is intended to make software design more understandable, flexible and maintainable. So solid is nothing but simply an acronym of 5 design principles. So this solid acronym was first introduced by Michael Feathers. So now let us have a look at what are those 5 design principles of the solid design principle. So the first one is the single responsibility principle. So in the word solid, S stands for single responsibility principle, then O stands for open closed principle, then L for Liskov substitution principle, then I for interface segregation principle, and finally D for dependency inversion principle. So now let us have a quick look at the definition of these 5 design principles. So first is a single responsibility principle. So a single responsibility principle basically says that a particular class should have only one reason to change, which means that you should not dump too many features into a single class, which is irrelevant to the responsibility that the class is holding. So which means that whenever you are designing a particular class, you should first establish what exact responsibility is this class going to handle. And once you have developed that particular class and you have written the code for that class and you basically have implemented that class and also you have tested that class, after that if you want to add more and more features into the class, then it would mean that you are basically breaking the solid design principle, which is nothing but the single responsibility principle. It means that once you have established that this is the responsibility my class is going to hold, and after that if you add more and more features which is not relevant to the responsibility of the class, but you just want to achieve more and more implementations from the same class, it clearly means that you are breaching solid responsibility principle. So which means that if you have multiple functionality to be implemented, then every module or class should have a responsibility over a single part of the functionality provided by the software. So it is not like if you have multiple functionality in your software, then you should implement all those functionality in a single class. So once you have decided the responsibility of a particular class, then that responsibility should be entirely encapsulated by the class. So I hope that you are able to understand the definition, but don't worry, in the upcoming videos we will also see the example of all these design principles. So for now, just try to understand the theoretical part of it. Okay, so the next solid design principle is the open close principle. So a quick definition of this particular principle will be a software entity should be open for extension but closed for modification. So which means that once you have created a particular class and you have implemented certain functionality into the class, and also you have tested and in fact moved that particular class into production, and in future now you get more and more functionality to be added as part of your software, then you should not basically make any modification in the class that you have already created. Which means that once a particular class has been created, it is allowed for you to basically extend the functionality, but you should not make modifications inside the class itself. This is what open and close principle states. So always remember that once you have created a class, implemented a particular functionality into the class, and then you have basically moved it to production after testing, and later if you get any requirement to make or add new features into your software, then do not straight away go and make modifications into the class that you have already created, because that would be breaching the open and close principle. So in order to add more and more features into your software, you can basically extend the class, but that class that you have already created is closed for any further modification. So as much as possible, you should avoid making any modifications into the classes that you have already created as part of the open closed principle. And also you must remember that the design and writing of the code should be done in such a way that new functionality should be added with minimum changes in the existing code. So right from the beginning, you should be designing or writing your code in such a way that in future, if you want to make any modifications into your code, it should be achievable with minimum amount of changes in the existing code. And also one more important point is that the design of your code should be in such a way that it basically allows adding new functionality as new classes, so that we are able to keep as less change as possible in our existing code. So I hope that the definition of open close principle is clear. Now let us move to the next solid design principle. So the next solid design principle is the Liskov substitution principle. Now this particular principle states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of the program. So let me try to explain a little more about this. So if a particular program module is using a base class, then the reference to this particular base class can be replaced with a derived class. And when you are doing this, it will have no effect on the functionality of the program module itself. Because remember that your particular program module is using the base class. So we can also say that the derived types must be substitutable for their base types. So if this is not making sense right now, then do not worry. We will see an example of this in upcoming videos, and then you will clearly understand what Liskov substitution principle basically means. So now let us move to the next solid design principle. So the next solid design principle is the interface segregation principle. Now what this particular principle states is that it is always good to have many client specific interfaces rather than having just one general purpose interface, which means that instead of dumping too many functionalities into a single general purpose interface, it is always good to segregate the functionalities and basically create many different client specific interfaces. It is a better approach, which basically means that we should not enforce clients to implement interfaces that they don't use. Which means that if you provide a single general purpose interface to the client, then there can be many different functionalities within the interface that the client may not even use. So instead of giving such a general purpose interface, or instead of creating one big interface, we can break it down to smaller interfaces. And in that way, we will be able to share only the usable interfaces with our client. So I hope that this particular design principle definition makes sense. But if it does not, then don't worry. Again, we will see the example in the upcoming videos. So now let us move on to the next design principle. So the last and the final design principle is the dependency inversion principle. So the dependency inversion principle basically states that one should depend upon abstraction and not concretion. So abstractions should not depend on the details, whereas the details should depend upon the abstractions. So we will see the example of this particular statement in upcoming videos. So don't worry if it does not make much sense. And also it states that high level modules should not depend upon low level modules. So having understood the definitions of these 5 design principles, now let us see that why they are so important and why is it basically mandatory to follow these solid design principles whenever we are designing an application using object-oriented programming. So first let us try to understand that what will happen if you do not follow these solid principles or the solid design principles. So the first and the foremost problem that we will end up with if we do not follow these solid design principles will be that we will end up having a code which is strongly coupled with each other, which means that a particular part of your code is basically coupled strongly with other modules or other part of your application. So tight coupling between different parts of your application would clearly mean that in the future, if you want to implement any new feature, then it will take more time to implement any new requirement. And also, if there are any bug fixes that you have to perform, it will take more time, and it may also be little vague to fix any particular problem, or you will have to spend more and more time to basically analyze what kind of impact this particular bug fix is basically causing in other parts of your code, because everything is so so strongly coupled with each other. So this is the first problem that we will end up if we do not follow the solid design principle. The second problem that we will end up with will be that our code will not be testable, because if you want to implement a particular feature and your code is so interlinked with each other or strongly coupled with each other, it clearly means that whenever you are adding a new feature or a bug fix, then basically you will have to end up testing everything once again. So you cannot basically focus on one part of your code and perform modifications on that specific part and do the testing of that specific code. So if your code is strongly coupled with each other, then it would clearly mean that whenever you are making any kind of modification based on a new requirement or even if a bug fix, you will have to end up testing everything once again. So this is the second problem, that it makes your code untestable. And the third problem that we will come up with is the code will have a lot of duplication, which is clearly a crime when it comes to programming. Forget about design principles for a moment. We are basically breaching the DRY principle, which is do not repeat yourself principle. And in future, when you accumulate all these modifications and changes that you are making inside your application code, which is strongly coupled with each other, this may lead to unknown issues in the application development cycle. So in order to avoid all these challenges or problems, we always need to follow the solid design principles. And if we follow solid design principles, then we could simply avoid all these problems in our application code. So having understood what will basically happen if we do not follow solid design principles, let us see what are the advantages that we will have if we follow diligently all the solid design principles. So the first advantage that we will get if we follow the solid design principles will be the most important thing, that we could avoid the tight coupling of our code, right? As I said in the disadvantages, that if we do not follow the solid design principles, it will basically mean that we are coupling a particular part of our code with other parts of the application. So if you follow solid design principles, then it will reduce the tight coupling between the different parts of your application. And then the second advantage of following the solid design principles will be it basically achieves reduction in complexity of your code. So your code will be more modular and it will be feature specific or responsibility specific, and your code will not be too much overloaded. So in this way, the complexity of your code will reduce significantly. And if the complexity of code is reduced significantly, it clearly means that it will increase the readability, extensibility, and also maintainability of your code in the future. And if your code is basically maintainable in the future, it clearly means that you will have less errors or reduced errors, and you can also basically reuse your code in other parts of your application. So since your code will be modular in nature, you can basically reuse a particular block of code in other parts of your application without creating any duplicate code. So since your code is less complex, it is readable, it is extensible, it is maintainable, it clearly means that your code must be extremely testable. So all these benefits of using solid design principles will make your code better testable. And later in future, if you are adding any new functionality into your code, then basically since your code is modular in nature, you can make a specific change on specific part of your code, and then you can test that specific part without disturbing any other part of your application. So these are the benefits of following the solid design principles right from the beginning. So as you can see that there are a lot of benefits of following solid design principles, and that is exactly why it is so important to understand all the solid design principles for all the developers. Because when you will be working in commercial projects, it will be very important for you to understand or have understanding of these solid design principles so that you are able to design an application which has a readable, extensible, and maintainable code. And this will eventually help you to create an application which is highly optimized. And also it will help you to basically make modifications into your code in the future. When you will be getting more and more requirements from your client, you can make the changes and also test your code easily. So always remember that whenever you are creating any new solution to develop a particular application for the client, it will basically depend on three aspects, or you can say that your success will depend on three aspects. One is how you are developing the architecture of your application, right? What are the different components that you are using in order to achieve a particular service, and how you basically design your architecture optimally. That will be the first thing. Second thing will be that are you following all the design principles while developing your application or not? So your success will highly depend on that factor as well. And the third will be what are the different design patterns that you are going to use in order to implement the features based on your customer requirement. So we need to use or choose the appropriate design patterns in order to build our software. So right from the beginning, you need to choose the right design patterns to implement the features of your application. So if you are successful in these three segments of your solution development for your application, then definitely your solution will be a success. So I hope that this video helped you to understand the importance of solid design principles, and also I hope that you are able to grasp the definition of all the solid design principles that we have. So from the next video, we will start understanding each and every solid design principles one by one. So we will see the examples of each and every solid design principle so that we are able to understand what they actually mean. So I know that some of the design principles in this video must not be clear to you, because explaining those design principles in this video without showing the example is actually fruitless. So for now, it is enough for you to just know the definition. In the upcoming videos, we will see examples of each and every solid design principles, and we will get complete understanding of those principles. See you in the next video. So if you like this video, then hit the like button, share it with other code lovers, and also subscribe to Code Framer for more videos in the future. Thank you, and see you next time.